Well, hello again. This video is our journal entry for the Pythagorean theorem. It's a fun one to say, even a more fun, or it's even more fun to spell. So good thing this is a math lesson and not a spelling lesson. So the Pythagorean theorem is actually one of the oldest and most interesting theories that we have in math. Actually, all construction and a lot. This has a ton of applications. It's probably one of the better math concepts to learn because it's actually you can use it in your own world. Construction people can use it to figure out if you have a 90-degree angle. So basically, if your corners are square, we can use the Pythagorean theorem to figure that out using the properties of a triangle. So, but in order to understand the Pythagorean theorem, we need to know the different labels for the triangles. So the Pythagorean theorem only deals with a right angle triangle. So you see we have a right angle triangle here. Any of the sides that are, so the two sides that go and form the vertex of the 90 degrees here, so we call them legs. So we have this side here, we're going to label it as A, goes and forms the point of the 90-degree angle, and this side of the triangle here, we're going to label it as B, and then also forms the point of the 90-degree angle. So those two sides that form the 90 degrees, we call them legs. The letter placement doesn't matter. We could put B here, we could put A here. It doesn't matter, okay? It was just as long as we understand that they're the legs. The one that we can't mess up labeling is something called the hypotenuse. The hypotenuse, its location is always the side straight across from the 90-degree angle, okay? That's called the hypotenuse, and we can't mess it up because it will mess up our equation. So we can change the A's and the B's, but our C is always going to be our hypotenuse side. Okay, so the concept of the Pythagorean theorem is this. Well, if we were to take this side and we were to create a square from the side length of this one, and by the way, we can label these the same way. This is side A, this is side B, so these are two legs. We notice them in this triangle that they are the same size. And then this one would be our side C because it's directly our hypotenuse because it is directly across from the 90-degree angle. So this one is to scale. I'm glad I'm using graph paper because if we look, if I was to create a square from this side, okay, so let's say this side length, we can actually calculate it is 2. This one is also 2 units, okay? This one we don't know, but we can figure it out, okay? So if we create a square from this side, we learn that it has an area of 4 units. 1, 2, 3, 4. This one is exactly the same size. It is also 4 units, okay? So the square on this triangle side and the square on this triangle side, 4 units large. So if I was to square this side, I get 4. Square this side, I get 4. So what's interesting is that if I add these two up, I should get the square size for this one. So 4 and 4 is 8. If we were to look at this, that actually works out. We have 4 units here. Okay, 1, 2, 3, 4. We have 2 halves. So 5, 6, 7, 8. That works for every single triangle. If I was to square this side and square that side and add them together, I would get this side length. So that constant that we have in our world allows us to use the triangle, the right angle triangle, to calculate lots of different measurements, and also it can allow us to make sure that our 90-degree angles are square, which means they are a true 90 degrees. So the concept is this: Pythagorean theorem says that a squared plus b squared equals c squared. Okay, if I square the a side of the triangle and square the b side of the triangle, if I add them together, they will give me the total for the c side. 4 plus 4 is 8. So that's the overall concept with the Pythagorean theorem. If we're given a triangle, so let's say we have this one, often we use the Pythagorean theorem to figure out what the side length is of one side of the triangle. That's what we would do in grade 8, is we want to use it to figure out a missing side length. We don't really care too much about the size of the square outside the triangle. We're actually wondering if we can figure out the side lengths. So here's our example. So if we have this one, and let's say this is 1, 2, 3, 4 units, okay? So we have 4, we'll say centimeters. And this one is 1, 2, 3, 4, 5 centimeters. Okay? We know that these are the legs, right? Because they are the two sides that are creating that 90 degrees. So we know that this one is going to be our C. We don't know what it is. Okay, so we can use the Pythagorean theorem to help us out. We know that a squared plus b squared equals c squared. So we can actually calculate c. Not c yet. We can still calculate c squared using this Pythagorean theorem. So now we plug in what a is and what b is. Now it doesn't matter which order it is, but we'll say that the a, and we'll even write down that we think that a is 4, and we think that b is 5, and we actually don't know what c is. Okay, sometimes organizing your information like this is great just to keep yourself organized. So a, we're saying, is 4. So 4 squared plus, plug in the variable for b, which is 5 squared. We don't know what they are, or sorry, we do know what they are, but we don't know what c squared is. Okay, so 4 squared is 4 times 4, so 16. It's not 4 times 2. And we go plus 5 squared is 25, which is 5 times 5, equals c squared. So we don't know what c squared is, but when we add these two up, we have 30 plus 11 is 41. So, in order to find the actual length of c, we have to understand that we actually have calculated now what c squared is. So we've calculated the actual size of the entire square that would be here. That doesn't tell us the side length, just like 4 doesn't tell us that the side length for a here is 2. We have to actually figure out what would be the side length of each one of these. We know it's 2 here. The only way to calculate this side length is actually to find the square root of 41. And that is what c is going to be. Okay, so the square root of 41, I'm going to write it here, c equals then, and we're going to have to use our calculator here. So I'll see if, hey Siri, no, it won't let me do it there. It might let me do it here. What is the square root of 41?
The square root of 41 is approximately 6.40312.
So 6.4 centimeters is what the length of c will be. So in order to use the Pythagorean theorem, you're going to have to have a calculator, because sometimes that's going to happen. And when you're dealing with square roots, it's not something that's going to be, it's not easy to figure out two numbers that multiply by themselves that give you an answer. So you're going to have to use a calculator, but that's the concept of how you calculate the hypotenuse, using the Pythagorean theorem. So I'll do another journal entry how to calculate the leg, just to keep this short. So that's how you calculate the hypotenuse. I'll do another video to show you how you can change this formula to calculate one of your legs. So let's say we know the hypotenuse, but we want to calculate a leg, an A or B. We can still use this formula, but we have to manipulate and change it so that it works for us, which we can do with any algebraic formula.